All right, this is a video about inverse functions. Let me encourage you to pause here and go get a pencil and paper and take great notes because you will be able to use your notes on the retake. All right, let's go on here. So what exactly is an inverse function? It's a function that undoes the original function. Just like division undoes multiplication, these are functions that undo the original. So let's take a look at some examples so you can see exactly what I mean. If I started with a function, f of x is equal to 2x plus 1, in that function, the input is multiplied by 2, and then we add 1. Well, in the inverse of that function, we see that we subtract 1 and then divide by 2. So everything that was done in the original function is undone with the inverse operation, such as we had multiplication and now we have division. We had addition and now we have subtraction. So you're going to be looking for that as a good eyeball test if you really want to know whether or not you did your work right. Here's another example. In this function g of x, we are squaring x and then subtracting 3. So in the inverse, we're going to be adding 3 and taking the square root. Now, I want you to notice these things that look like exponents. That is inverse notation. If I see f of negative 1, f to the negative 1 power, I know that means that this is the inverse of the function f. G to the negative 1 power, they're not really exponents, but I'm using this verbiage to be really clear about what I mean. I know that that is the inverse of the function named g. So, what are some important things to know about inverses? The first and probably most important thing to know is that between a function and its inverse, all the x and y values are switched. So if this is a table of the function f of x, some random function, then this is the table of the inverse of f of x. You can see that all the x and y values are totally switched. If this is a set of coordinate pairs for the function g of x, then the coordinate pairs for the inverse has the x's and y's switched. So the first important thing to know is if you have the xy values from a table, from a list of coordinate pairs, or from a graph, you can literally switch the x and y's and create a new table or a new list of coordinate pairs or even a new graph for the inverse. Number 2, the domain and ranges are switched. Now, since I just told you that the x and y values are switched, and you know that domain is x values and range are y values, this should make total sense. That means if I know the domain of a function, I can know the domain and range of its inverse just by switching the domain and range. Here's an example here with coordinate pairs. Here's an example here where I know that I started with a function f of x that had a domain of all real numbers and a range from 0 to positive infinity. I can just switch the domain and range and know the domain and range with certainty of the inverse. So what was the range becomes the domain of the inverse. And what was the domain becomes the range of the inverse. So if you know the original function's domain and range, you also know the domain and range of the inverse because all you have to do is switch them. Number 3, When you graph a function and its inverse, they are always symmetrical around the line y equal x. Other words, they're reflections around the line y equal x 100% of the time. Here are examples of two graphs. In this first graph, this green dashed line is y equal x. The blue line is the original function, and the red line, this reddish line here, is the inverse of the function. And you'll notice we used inverse notation, and they are symmetrical around the line y equal x. Also, in this example, we have x squared plus 1, and we have this lovely pink parabola here. Here's the line y equal x, and this green graph is its inverse. Now, whenever we take the square root of something, we have to do plus and minus, so I did that here, and here we go. Here is the inverse, and you can see that they are reflections over the line y equal x. Number 4, just because you started with a function, it doesn't mean that the inverse is a function. You have to apply the vertical line test to determine if the inverse is also a function. So let me give you an example using the previous two graphs. Here we have the linear function y equal 2x and its inverse of x minus 1 divided by 2. I'm going to apply the vertical line test, which means I can draw a vertical line anywhere on this graph, and if it only passes through the graph of the inverse once, then it is a function. Now, if I took this purple line and moved it to the right, it would only pass through the graph of the inverse once, no matter where I put it. That means the inverse definitely is a function. But in our second example, when I apply the vertical line test, I notice that it passes through the inverse twice. That means the inverse is not a function. In summary, there are 4 things you must know. The x and y values are switched. The domain and ranges are switched. The graph of the original function and the graph of its inverse are reflections of each other about the line y equal x, and the inverse of a function may not be a function. You have to apply the vertical line test to determine if it is a function. Now, I hope that you took good notes. If you don't have good notes, watch this again, pause as much as you need to, and make sure you have great notes that you understand and that will make sense to you later. Hope this was helpful. See ya.